Hey, what's up guys? Shiv here. I'm Shiv, and this is
Whayden Domtra.
and today we're going to be using related rates to find the rate at which the distance between a moving car and a balloon rising upwards increases. Yeah.
So as you can see, for our calc project, we're going to be using this vehicle right here. Within this vehicle we have balloons. I don't know if you can see, but there are a couple balloons in there.
We have 3 just in case we mess up the first 2 times.
So basically, an overview of what this project is that we're going to utilize the Pythagorean theorem, and we're going to find the derivative in relation to time of all different aspects, which is the x displacement, y displacement, and let's just say theoretically the z displacement, which is the diagonal distance between the car and the balloons that would be floating up.
Exactly.
With the Pythagorean theorem, we know that the derivatives of the displacement is going to give us the velocity. And in this project, we're going to have the car, which is initially going to accelerate to go from 0 to eventually have a constant velocity.
Exactly.
And then we're going to have the balloon, and we looked this up. Helium balloons, which we have over here, have a constant velocity and they're increased towards the sky. We'll use a speedometer And to calculate the velocity of the balloon, we're going to use our camera that we have set up here, and we're going to measure the height and divide it by the time that we have to find the meters per second and how fast it goes up.
Exactly. So yeah, that's basically an overview. So we're gonna cut to the car driving, and then we'll meet you guys somewhere inside so we can show you guys the exact calculations on how to do it. Our car of choice for today is a 2017 Lexus GX. Our fateful balloon that is going to be released is this yellow smiley face balloon. So
Welcome everyone. Today I'm going to explain the brief overview of this problem that we will solve. It's between a car and a balloon, and you can see the system creates a right triangle. Therefore, we're going to use the Pythagorean theorem. Now, where did we get our values? Well, while we were taking the video, we found the length of the average SUV that we used, and we multiplied the pixel length of each car and mapped it over the distance between the vertical line crossing through the balloon and made it perpendicular with the length. This gave us a distance of 14 meters. With the same method, we mapped the vertical length from the balloon to the floor, which gave us a distance of 5 meters. Then we looked up what was the average speed of a helium balloon that rises, and it said 3 meters per second. This is when we factor in all environmental factors and tendencies in nature. Now, on the other side, we have the GX, the car that we drove. When we were looking at, to find the velocity, we did the distance of 14 meters divided by the time that it took, giving us a speed of 9 meters per second. Now, the problem that we want to solve is not only what the distance z, which is the diagonal distance between the car and the balloon, but also the rate at which that distance is changing. And that is what Shiv will solve for you today.
Alright, so we're going to start off this problem by writing down the Pythagorean theorem. We are in AP Calculus, so I'm assuming everyone knows what it is, x squared plus y squared equals z squared. So our values are, the car is 14 meters away from the origin, and the balloon is 5 meters in the air, and we want to find the distance between these, so we can have the actual distance between the car. So then, solve it. Square 14, you get 196, 5 squared is 25. So z squared is the square root of 221. So when you actually do the square root of 221, you get that z is equal to 14.866. So we want to write down the Pythagorean theorem again so we can take the derivative of it, so we can find dz dt, which is what the answer to this problem is. So we take the derivative of the entire equation, and when you do this, you'll get 2x dx dt plus 2y dy dt equals 2z dz dt. So then now we can plug in all the variables. So we know that x is 14, dx dt is 9 meters per second, and y is equal to 5, and dy dt is equal to 3 meters per second. And we know that z is equal to 14.866. So all we have to do is rearrange the equation to finally solve for dz dt. So we're going to multiply the 2, 14, and 9, and that gets 252. And then 2 times 5 times 3 is 30. And 2 times 14.866 is 29.732 times dz dt. So when you finally solve for dz dt, you get that the answer is 9.485 meters per second. And that is how much the distance is increasing at that exact instance in time. So there's the answer. Cool.
So today, our car of choice is Whayden's mom's Lexus
No,
GX.
you say the Lexus. You don't say Whayden's mom.
Yo!